Hello everyone. Our lesson today it's about current in a simple circuit. Firstly, in this lesson we will talk about we will explain what do you mean by current, and also we will explain what do you mean by circuit or electric circuit. An electric cell, which is battery, this battery, it can make the electrons move, but only if there will be a something that it will conduct the two terminals of it. This battery, it has electrons in it, okay, or it will let the electrons to flow through it only if you will connect the two ends of it or the two terminals of it. When these two terminals will be connected with each other, what will happen? A chemical reaction will take place, or it will happen inside this battery. And as a result of this, the electrons, it will start flowing. Now, if you will take a look on this diagram, here what do we have? We have a battery, wire, lamp, and switch. If you will connect the two ends of this battery and you will close the switch, what will happen? The electrons here, it will start moving. As you can see here, these arrows, it shows the direction of the electrons, or how the electrons it will move. Now, when you will close the switch, what will happen? This lamp, it will glow. How or why? When the electrons are passing through this wire, when it will reach this point, it will pass through the filament. Here we have something, we call it filament. When the electrons, it will pass through the filament, so it will heat up the filament. As a result of this heating, what will happen? The filament will start glowing. Now, the path of battery, wire, switch, lamp, all of it, we call it a circuit. Okay? Definition for circuit, you'll say the conducting path through the lamp, wires, switch, and battery is called a circuit. Now, the electrons are flowing in this electric circuit. But if you will switch off, or if you will open the switch, now what will happen? The electrons, it will start flowing. Why? Because we don't have a complete circuit. This electric circuit, when you will draw it, you can draw it by using symbols. If you remember in grade 9, we talked about these symbols. For example, here what do we have? We have battery, we have wire, switch, and lamp or bulb. But this electric circuit, it's the same as this one, but here we draw it as symbols. Now, these two lines, one big and small, these lines, it represent the cell, okay? Here, it represents a single cell, and always the tall arm or the tall line, it represents the positive end. And straight line, it represents the wire. Switch, these two lines, okay, it represents the switch. But here the switch, when it is an open switch, sorry. If they will say a closed switch, what will happen? This line, it should touch this one. And what do we have here? We have lamp, okay? This a circle, and inside it a X inside it. This, it represents the lamp. One information here, or it is electric charge can be positive or negative. And as we explained before, as we said, when you have two same charges will repel each other. when you will have different charges, these different charges will attract each other. Now, this charges always it needs a material that it will let these charges to pass through it. We call it conductor. Now, the wire that we used here, it's an example of conductor. Why? Because it let the charges to pass through it. Example for conductor, we will say copper. Now, these charges, okay, the unit that we use it to measure the charge, it's what? It is coulomb, or we use the letter C as a shortcut. Now, we said the electrons will pass through this electric circuit, okay? Now, this we call it current. Now, how we can measure the current? A definition for current, you will say a flow of charge is called current, electric current. When the charges are flowing through this electric circuit, this is the current. Now, how we can measure the current? The higher the current, the greater the flow of the charge. To measure the current, electric current, we use a tool or instrument, we call it a meter. Okay? A meter, it's the tool that we use it to measure the electric current. When we will measure the electric current, we will measure it with a unit. What do we call this unit? We call it ampere. The standard international unit, or the SI unit of electric current, it's what? It is ampere. We use the symbol A to represent it. Sometimes the amount of the current in an electric circuit, it will be less than 1 ampere. For example, now this ampere, okay, it's what? It's using 1 ampere. But sometimes to measure a current, you need to choose a meter with a suitable range on its scale. This ammeter cannot measure currents above 1 ampere, okay? Also, to measure, say, 0.1 ampere accurately, it would be better to use a meter with a lower range. For example, you are trying to measure the current in a specific electric circuit. Let's say maybe the electric current here, maybe it's 10 amperes. Okay, this tool now, the maximum of it, it will be, for example, let's say 5 amperes. Can you use it? No, of course no. So you should always choose a suitable tool to measure the electric current of a specific electric circuit. To measure the electric current, when you will use this ammeter, if you will look at ammeter, you will see it has two ends. One it's black and one it's red. How to connect it to the electric circuit? Always the red end, it should be connected with the positive side, positive end of battery. For example, now this is the battery. As you can see here, we have positive and negative. Now, if we want to put this ammeter in this electric circuit, how we will connect it? We should connect the red end with the positive. This is the correct way to put the ammeter in the electric circuit, and also to measure the electric current in this electric circuit. We have another unit. We use it to measure the electric current, which is smaller than ampere. We call it milliampere. So if you will use a meter, so the unit of it, it's ampere. But if you will use milliammeter, the unit of it, it will be milliampere. And 1000 milliampere, it's equal to 1 ampere. Some typical current values. For example, current in a small torch lamp it is what? It is 0.2 ampere, or it is 200 milliampere. Current in car headlight lamps, it's 4 ampere. Current in an electric kettle element, it's 10 ampere. Here, this electric circuit, we have a cell, wires, and lamp. And in addition to this, what do we have here? We have two ammeters. Two ammeters, they put two ammeters in this electric current to measure in this electric circuit to measure the electric current. The ammeter will has no effect on the amount of the current. For example, here we have the cell and it's giving a specific current, okay? Now look at this, the first ammeter. Now here it's what? 2 amperes, and then the current will pass through the lamp and then will go to the next ammeter. But also the reading here, it's what? It's 2 ampere. What's that mean? It means that putting the ammeter in the electric circuit, it will never affect on the amount of electric current. So putting ammeters or milliammeters into a circuit has no effect on the current. So in general, you will say the current is the same at all points in a simple circuit. Charge and current. Now we talked about charge and also we talked about current. There is a connection, there is a link between charge and current. What is this link or what is this connection? If a charge flows at this rate, then the current is this much. Example, if 1 coulomb per second, okay, it's equal to 1 ampere. 2 coulombs per second, then 2 amperes, the current will be 2 amperes, and so on. 3 coulombs per second, it means the current will be 3 amperes. 4 coulombs per second, it means the current will be 4 amperes, and so on. The link can also be expressed as an equation. This equation, it shows the relationship between charge and current. The equation, it says charge, it's equal to current times time. Okay, if we want to find how many charges, the amount of charges, how we can find it? We should know the amount of current during a specific time. Okay, the unit for charge, it's coulomb. The unit for current, it's ampere, or the unit for time, it's second. For example, here we have this example. If a current of 2 amperes flows for 3 seconds, the charge delivered, it will be how much? If you will apply this equation, you will write, instead of current, you will write 2, instead of time, you will write 3. Now, sorry, 2 times 3 equals to 6 coulombs. This is the equation that it shows or that shows the relation, or that it connects the current with charge. Current direction. Firstly, again, let's give definition for current. Current, we say it's the flow of charges. Okay, the flow of electrons. Now, as we mentioned before, the electrons, it will move from negative to the positive. Okay, when you will see, whenever you will see electric circuits, you will see these arrows. These arrows, it shows the direction of electric current. Okay, but this electric current or electrons, always, as we said, it will flow from negative terminal of battery to the positive terminal. Okay, but sometimes you will have an arrow that it's in opposite direction. It is from positive to the negative. Okay, so what is the first one and what is the second one? The first one, that it's from negative end to the positive end, this we call it electric current, okay, which is the flow of electrons, the negative electrons, okay. At the same time, there is another current, we call it conventional current. What's conventional current? Conventional current is the current with the direction opposite to the flow of negative charges. In other words, we will say it's the flow of positive charges. Okay? The direction of conventional current, it's always from positive to the negative. It's opposite to the electron flow. Is that clear? The conventional current direction is equivalent to the direction of transfer of positive charge. Okay? The positive charges, it will travel, or it will flow from positive to the negative. So conventional current direction, it's with the direction of positive charge. But maybe now you will ask, but Mr. which one is correct? Now what shall we say? The current, is it from negative to positive or from positive to negative? Okay, the answer it will be, firstly, scientists, they discovered this the positive charge, okay, and they said the direction, the electric current, it's from positive to negative. But later, when they discovered the electrons, they found that the electric current direction, it's always from negative to positive. Why? Because then they discovered that the electrons are able to travel, are able to move, but the positive charges are unable to travel. Okay, so it's not wrong, it's not a mistake if you will say it's from positive to negative, but to differentiate between these two flows, it's either you will say electron flow or conventional current. When you will say electric current, you mean by it electron flow. So how the electrons will flow? Electrons will flow from negative to the positive. But if you have a question, it says, what is the direction of conventional current? You will say it is from positive to the negative. So you need to focus on the question. What does the question say? Is the question about electric current, or it's about conventional current? Now, let's solve the questions. Question number 1, it says, convert this current into amperes. A, 500 milliampere. B, 2500 milliamperes. Firstly, here we will convert from what to what? We will convert from milliampere to what? To ampere. Now, we are converting from what to what? We are converting from small unit to big unit. Because we are converting from small to big, so what we will do, we will divide. We will divide by how much? We will divide by 1000, because as we said, 1000 milliampere equals to how many amperes? It's equal to 1 ampere. Now, what do we have? How many milliamperes we have? Now you will say ampere equal to how many milliamperes we have? 500 over 1000. The answer, it will be 0.5. Okay, 0.5 amperes. Now, if we will solve the second one. The second one, we have 2500 milliamperes. The same way, you will say amperes equal to how many milliamperes do we have? We have 2500. You will divide it by what? You will divide it by 1000. Now the answer will be how many amperes? It will be 2.5 amperes. This is the way to convert from milliampere to ampere. If the question will be opposite, if the question will give you ampere and will say convert it into milliampere, now you will convert from big to small. From big to small, always you will multiply. You will multiply by how much? You will multiply by 1000. Question number 2, convert this current into milliamperes. So this, it will be your task. I did the first one from milliampere to ampere. Now it's your turn to do from ampere to milliampere. If you will just focus on how I solved the first question, now you can solve the second one. Question number 3. A. Draw the circuit on the right using circuit symbols. Instead of this electric circuit, you will draw it, but this time by using what? By using symbols. Now, which symbol you will use? You have wires, okay? You will come back to this one, to these symbols. You will use these symbols. B. On your diagram, mark in and label the conventional current direction and the direction of electron flow. See, what do we have? Conventional current and electron flow. As you know, as we explained before, we said one is from negative to positive, the other one is from positive to negative. They are opposite to each other. Now, let's start with conventional current. Conventional current, we said always it's from positive to the negative. So the arrow or the conventional current, it will be by this direction. But if you will come to electron flow, electrons are negatively charged. So you will start from the negative terminal, the negative end. So the direction, it will be by this direction, from negative to the positive. C. The current reading on one of the emitters is shown. What is the reading on the other one? Here, this emitter, as you can see, it is what? It is 0.5 amperes. Okay, if the first one is 0.5 amperes, how much it will be the reading on the next one? Okay, both of them, they are connected to the same electric circuit. If the first one it's 0.5, so the second one, how much it will be? Also, it will be the same, because when we explained about the emitter, we said it will always it will gives the same reading. Okay, the current is the same. Okay, the current is the same at all points in simple circuit. So here, if it's 0.5, also here it will be 0.5. D. Which lamp will go out if the switch contacts are moved apart? Give a reason for your answer. The answer here, it will be both of them, A and B. Why? Here, this switch, it's what making the electric circuit complete electric circuit. So if you will take the switch away, so what will happen? Now there will be a gap here. These two wires will not be connected to each other. So at the end, there will be no electron flowing. So at the end, none of these lamps or these bulbs will turn on. Question number 4. What charge is delivered if a current of 10 ampere flows for 5 seconds? As we explained, we said there is an equation that it shows the link or that shows the connection between current and charge. So here in this question, we want to find the charge. Here we have current and we have time. Okay, just by applying this equation, what we will do now, you will just replace the words with numbers. How much is the current? It's 10. How much is the time? It's 5. So 10 times 5, the answer will be 50. 50 what? 50 C or 50 coulombs. Let's solve this one. You will write the equation. The equation, it says charge, okay, equals to current times time. Now, how much is the charge? We want to find it. How much is the current? It is 10. Times, how much is the time? It's 5 seconds. Now, the answer will be 10 times 5 equal to 50. 50 what? 50 C, or you can write coulombs. Don't forget to write the unit. B, you will do it. It will be your task. You will do it by yourself. B, it's the same. A current of 250 milliampere flows for 40 seconds. But how to solve this one? You need to focus on the units. Okay, the units, it should be same as these units. How? What's the difference here? Instead of ampere, you have milliampere. Now, in this case, what you will do, you need to convert this milliampere into ampere, then you will solve it. Dear students, that was everything for this lesson. I hope you got benefit from it. And again, please watch the video and write a comment. If you still have any questions, concerns, write your question in the comments, or if you want, text me. Thank you and have a good day.